For centuries, humanity has explored the universe using one remarkable tool: observation. From the earliest skywatchers who mapped the stars with their eyes to modern space telescopes orbiting far beyond Earth, every generation has built more powerful instruments to answer the same timeless questions. How did the universe begin? How do galaxies evolve? Are there other worlds capable of supporting life? Today, those questions are being explored in ways that were impossible only a decade ago. The James Webb Space Telescope has become one of the most advanced scientific observatories ever built. Its giant segmented mirror and highly sensitive infrared instruments allow it to detect faint light that has traveled across the universe for billions of years. Every observation collected by Webb is much more than a beautiful image. Behind every photograph lies an enormous collection of scientific measurements. The brightness of distant stars. The chemical composition of planetary atmospheres. The temperatures of cosmic dust clouds. The motion of galaxies. The wavelengths of ancient light. Each observation contains millions of individual data points waiting to be analyzed. As Webb continues exploring the universe, the amount of information it produces has become extraordinary. Astronomers are no longer studying hundreds of objects. They are studying millions. Traditional methods remain essential, but manually examining every observation would take an enormous amount of time. That challenge has opened the door to one of the fastest-growing technologies in modern astronomy: artificial intelligence. Rather than replacing scientists, AI acts as an incredibly fast research assistant. Machine learning systems can compare enormous collections of observations, identify similarities, highlight unusual objects, and detect subtle patterns that might otherwise remain hidden. Imagine searching for a single unusual shell on an endless beach. A person might spend weeks looking. An intelligent computer can examine millions of possibilities within minutes and point researchers toward the most interesting discoveries. This ability has become increasingly valuable as astronomical surveys continue growing larger. Modern observatories record far more information than any single research team could analyze alone. Artificial intelligence helps organize this information, allowing scientists to focus their attention where it matters most. One important application involves identifying galaxies. Instead of manually classifying every galaxy by its shape, color, and structure, AI systems learn from previously studied examples. After training, they can recognize spiral galaxies, elliptical galaxies, irregular systems, and unusual objects with remarkable speed. This dramatically reduces the time required to organize enormous sky surveys. Artificial intelligence is also helping astronomers search for exoplanets. When a planet passes in front of its host star, the star's brightness decreases by an extremely small amount. These tiny changes are often buried beneath noise created by instruments or natural variations within the star itself. Machine learning algorithms can recognize these delicate patterns far more efficiently than traditional search methods, helping researchers identify promising planetary candidates for further study. Another exciting area involves gravitational lensing. Massive galaxies and galaxy clusters bend light traveling through space, producing distorted images of even more distant galaxies. These distortions are often incredibly subtle. AI systems can analyze millions of galaxies simultaneously, measuring tiny changes in their shapes to help scientists map invisible dark matter throughout the universe. The technology is proving equally useful for studying stellar explosions. Every year, telescopes discover thousands of supernovae, variable stars, and other transient events. Artificial intelligence can automatically detect these changing objects, classify them, and immediately notify astronomers so larger telescopes can begin detailed observations before the events fade away. Perhaps the greatest strength of AI is not speed alone. It is consistency. A computer never becomes tired after analyzing thousands of images. It applies the same methods to every observation, helping researchers identify patterns that might otherwise be overlooked. Yet despite these impressive abilities, one fact remains unchanged. Artificial intelligence does not make scientific discoveries on its own. Every interesting signal must still be examined by astronomers, verified through repeated observations, and tested against established scientific models. I suggests possibilities. Scientists determine whether those possibilities represent genuine discoveries. This partnership between human expertise and advanced computing is creating a completely new way of exploring the universe. Instead of replacing curiosity, technology is expanding it. And as the James Webb Space Telescope continues collecting extraordinary amounts of information, this collaboration may lead to discoveries that no one expected when the mission first began. Every generation of astronomers has faced the same challenge. The universe always reveals more information than humanity can examine alone. Centuries ago, scientists carefully recorded the positions of stars by hand. Later, photographic plates captured thousands of celestial objects at once. Today, modern observatories collect more information in a single day than researchers once gathered during entire careers. The James Webb Space Telescope is one of the biggest contributors to this new era of discovery. Every observation contains enormous amounts of scientific data, far beyond what can be appreciated in the stunning images released to the public. Hidden within that information are tiny variations in light, subtle chemical signatures, precise temperature measurements, and clues about objects billions of light years away. Finding meaningful patterns inside such vast datasets is one of astronomy's greatest challenges. This is where artificial intelligence has become an essential scientific tool. Instead of searching manually through millions of observations, researchers use machine learning systems to organize information, compare similar objects, and highlight unusual features that deserve closer investigation. These systems do not replace scientific reasoning. They simply allow astronomers to work faster and more efficiently. Imagine trying to read every book inside the world's largest library to find a single important sentence. For one person, it would be impossible. An intelligent computer can rapidly identify the books most likely to contain useful information, allowing researchers to focus on careful analysis rather than endless searching. This same principle applies to astronomy. AI is now helping scientists detect rare cosmic events that might otherwise remain unnoticed. When a distant star suddenly brightens, a galaxy changes appearance, or an unusual burst of radiation reaches Earth, automated systems can recognize the event within seconds and alert observatories around the world. Rapid detection is especially important because many astronomical events last only a short time. Some stellar explosions fade within days. Others change over only a few hours. By responding quickly, astronomers can collect valuable observations before these events disappear. Artificial intelligence is also improving computer simulations of the universe. Researchers build detailed models showing how galaxies grow, how dark matter influences cosmic structure, and how stars evolve over billions of years. AI helps compare these simulations with real observations from Webb, identifying where theories agree with reality and where improvements may be needed. Sometimes the differences are small. Other times they reveal entirely new scientific questions. This process allows astronomy to progress through continuous testing rather than simple speculation. As future observatories begin operating, the importance of AI will continue growing. Next-generation telescopes are expected to observe billions of galaxies, discover thousands of new exoplanets, and monitor changing regions of the sky almost continuously. Without advanced computing, analyzing such enormous collections of information would become increasingly difficult. Yet despite these remarkable advances, the most important part of every discovery remains human curiosity. Artificial intelligence can recognize patterns. It can sort information. It can estimate probabilities. But it does not ask why those patterns exist. That responsibility still belongs to scientists. Every unusual signal identified by AI must be carefully examined, independently verified, and tested using established scientific methods before researchers can draw reliable conclusions. This careful process protects astronomy from false discoveries while ensuring that genuine breakthroughs stand on solid evidence. Perhaps the greatest achievement of combining telescopes with artificial intelligence is not speed. It is opportunity. Scientists can now investigate questions that once seemed impossible to explore. How do galaxies assemble over billions of years? How do planetary atmospheres evolve? How is dark matter distributed across the universe? Could there be entirely new classes of astronomical objects waiting to be recognized? Each new observation brings researchers closer to answering these questions. The James Webb Space Telescope continues collecting ancient light that has traveled across the cosmos for billions of years. Artificial intelligence helps transform that light into meaningful scientific knowledge. Together, they are opening a new chapter in humanity's exploration of the universe. Not by replacing human discovery, but by giving scientists better tools to uncover the remarkable story written across the stars.